Hi, this is James. Today I'm here with Bill Gosper explaining the taxman problem.
And this is Bill Gosper here, making things difficult for James.
So, how this problem works is on an annual basis, you get a gold disc which has radius 1, and you have to give the middle circle with radius r to charity, and you have to give the rest as the visual, or another portion as the visual shows, to the taxman, and you're trying to maximize your take-home pay. So how I solve this is I know when charity goes to 0, then the taxman will have exactly half of the gold disc. And when taxman goes to 0, charity will have the whole gold disc and you won't get any. So you know that you have a graph which has something like when it's a half, or when charity is 0 and the radius of charity is 0, r is 0, you get half. And then it goes up a little and then it goes down, and when charity is all of it, you get 0. So how to solve this is you need to find when the radius of the charity circle is equal to this chord here.
No, the circumference of the charity circle.
Or yeah, the circumference. So the circumference of that charity circle is 2 pi r, and half this chord from the taxman is, using the Pythagorean theorem, since we know this is the radius of the gold disc, which is 1, then this is half of this chord is root 1 minus r squared, using the Pythagorean theorem, and then that times 2 is 2 times root 1 minus r squared. And when that equals 2 pi r, we have to figure out what r is equal to. So we have 2 pi r equals 2 times root 1 minus r squared. So how I solved this equation, now that we have left, is I squared both sides to get 2, and squared both sides and divided by 2 to get pi r in parentheses squared equals 2 times 1 minus r squared.
You divided by 2 on one side but not the other.
Oops. So just 2 times 1 minus r. 2 times 1 minus r squared. And then what I did is I divided by r squared on both sides, because this pi times pi r squared is really pi squared times r squared. So I divide by r squared on both sides and I get pi squared equals 1 over r squared minus 1. And then I add 1 to both sides. So I get pi squared plus 1 equals 1 over r squared. And then you can reciprocal the whole equation, and you get 1 over pi squared plus 1 equals r squared. And then to isolate r, you square root the whole equation, and you get root 1 over pi squared plus 1 equals r. So when the radius of the charity circle equals root 1 over pi squared plus 1, then you maximize your take-home pay.
Oh, before you turn that off, one correction. You said an annual basis. And when you punch a hole in a circle, that's an annular basis. That was my little sneaky joke. Okay.
And we know this is the right answer because...
Well, if we increase the radius of the charity hole by dr, then we will lose circumference times dr, that's 2 pi r dr, to charity, but we will gain against the tax man the length of that chord times dr. So just equating the length of the chord to the circumference of the charity hole is the point of vanishing returns, and that has to be the maximum of this function. So that's sort of doing the calculus reasoning without doing the calculus.
When I first saw this problem, I thought, if the gold disc is worth $1 billion, why don't you just give half of it to Taxman and take the other $500 million? Because I'd be happy with that.
I would be unhappy with that because that would indicate the worst inflation I'd ever seen. So it's a good thing we worked it out.
I've heard better chirps from a dead bird.